Greeting. We are the group in this era. This is our final project, demonstration of classification methods based on 2 datasets. We divided the entire presentation into 2 parts, one for dataset 1 and another for dataset 2. We follow the 5-step routine learned in the lecture. For dataset 1, first we will acquire the data from CSV file and turn them into the form of data frame with pandas library. The training set had 552 rows. Validated set have 150 rows. Test set have the same size of the validated sets. Next, we need to do the pre-process the data. The dataset 1 is totally numeric. Then we apply dropping and filling methods for the empty slots, which depends on different test results. Sometimes dropping an entire row may have a better performance than filling. We also apply z-score normalization to normalize these columns, because some have different range of values, for example, like A4, A5, and A7. We test several models based on the sklearn library, and the multivariate logistic regression shown the best accuracy when not finely tuned these models. So for the first dataset, we use multivariate logistic regression for this implementation. Although it's called a logistic regression, it's essentially an algorithm suitable for classification problems, and we convert the labels to this format using one-hot encoder to process the data rather than calculating it directly and run it up. The optimization algorithm is gradient descent. Since data is multi-phases, we replace the sigmoid function with softmax. Overfitting can be easily occur when the dataset is small, for example, like 552. So we add L2 norm to mitigate this. The regularization part of the code is presented as a derivative in the gradient part of the code. So the next is the performance of dataset 1. The next part is about the dataset 2.
Now let me show you what we did with dataset 2. If we look at the dataset 2 in general, we can see that there are no missing values in dataset 2. Attributes contains both continuity and categorical data. So the next step of data cleaning is relatively easy. Next slide. Data cleaning in dataset 2 mainly falls into 4 categories. For yes/no data like attribute 1, we can simply divide it into 0, 1 variables. For the attribute 4 such data, we can, according to its meaning, there will be no, sometimes, frequently, always. According to the data, we can encode it to 0, 1, 2, 3. There are some missing values too. We just simply set it to 0. With attribute 11, we cannot understand the true meaning of the data, so we simply encoded different data. For the data of attribute 14, we can see that its data distribution ranges from 15,000 to 60,000. The data decision tree is too complicated to calculate, so we discretize it into 6 intervals, which can speed up the decision tree calculation, but we don't need to desecrate the card regression tree. Next slide. Since this is a multi-classification task, 6 classifiers from sklearn, including decision tree, KN, logistic regression, SVM, SGD, and naive Bayes were initially selected for prediction. The best performing classifier is the decision tree, and the worst performing classifier is naive Bayes. So we decided to build our own decision tree model and improve it. Next slide. First of all, we are familiar with ID3 decision tree. We know that ID3 uses information entropy for classification and classify based on the category that provides the most information gain. Different from ID3, Gini index is used in CAR to measure the impurity during splitting. Gini index is used because it is faster to calculate than entropy. Next slide. We use boosting as a promotion means, as shown in the picture on the right. Boosting means that they can only train a weak classifier each iteration, and the trained weak classifier will participate in the next iteration. And GBGT is used residual approximation to fit a card. The performance of our decision tree and our improving mode of GBGT is as follows. Okay.